Hey guys, we're back for balancing redox reactions. So now that you all know and are all experts at assigning oxidation numbers, now we can do something with those numbers that you've assigned. Because as you learned before, oxidation is an increase in oxidation number and reduction is a decrease or a reduction in oxidation number. So to balance redox reactions, you have to use these oxidation numbers and the electrons that they represent to balance the reactions. So these are the steps of the reaction, or rather, I'm sorry, these are the steps to balance a redox reaction. The first step you are already experts at, and that is to assign oxidation numbers. You'll need to assign oxidation numbers to the reactants and then to their corresponding products. So our first reactant is, and of course this is silver and aluminum. This is the reaction from our tarnished bracelet. This is the reduction of the silver to remove the tarnish. So our first reactant is a silver ion, and as we know, monatomic ions have an oxidation number equal to their charge. So its charge is +1, so its oxidation number is +1. The next reactant is aluminum. It's aluminum foil, so it's pure aluminum or elemental aluminum, so it has an oxidation number of 0. And that's our reactants. On the product side, we have pure silver, so that has an oxidation number of 0, and an aluminum ion, so that has an oxidation number of +3, which is equal to its charge of +3. Alright, so that's step 1. Step 2 is to identify RHR and OHR. HR stands for half reaction, so the RHR is the reduction half reaction, while the OHR is the oxidation half reaction. So silver, let's look at silver. Silver's oxidation number goes from +1 to 0, so it goes down. So we say that it is being reduced. So this is our reduction half reaction, is the silver part. Now that means that our aluminum, which is going from 0 up to +3, is being oxidized. So that is an oxidation half reaction. Okay, so that's step 2. Step 3 is to write these half reactions. It doesn't matter which one you write first. We're going to start with our oxidation half reaction. So our OHR. Our OHR starts with pure aluminum with an oxidation number of 0 and ends up with an aluminum ion. Alright, now, and then our reduction half reaction is silver ion to elemental silver. Okay, so that's our half reactions. Now to balance these half reactions we have 4 steps. So I'm going to go through A and B for each one, and then E has to do with both of them. So 4A says balance all of the elements. So we look at our oxidation half reaction and aluminum is already balanced, so we don't have anything to do for 4A. 4B is to add electrons to balance the charges, because since these are only a half reaction, instead of being able to show an electron jumping from one to the other, the electrons will just kind of be hanging out until we put everything back together. So we're going to use electrons to balance the oxidation numbers or the charges. So this is 0 and this is +3. Electrons are negative, so there's no way we can put electrons on this side to balance it. But if we put 3 electrons over here, the +3 and the -3 will cancel out to give you the 0. So now we have balanced our elements and our charges for oxidation, and now we'll do the same thing for reduction. Once again, the elements are already balanced, but our charges are not. We got +1 here and 0 here. So this is 1, we got to add 1 electron here to cancel out our positive. So this is our oxidation half reaction and our reduction half reaction. I kind of squeeze these in because we don't have a lot of space on this paper, but you do want to make sure you leave plenty of room on your half reactions to add the electrons on either side. So now step 4C is to balance the electrons by multiplying by the lowest common factor. Because these, like I said, these are half reactions. So what this is saying is for aluminum to go from its elemental state to its ionic state, then it must donate 3 electrons. However, for silver to go from its ionic state to its elemental state, it only has to gain 1 electron. And as we know, you can't give up electrons unless there's somebody to take them. So aluminum will need 3 silvers to take all 3 of these electrons. So the way that we balance this is by multiplying this whole reduction half reaction by 3, because our electrons have to be the same. So 3 electrons plus, 3 silver ions yields 3 silver atoms. Okay, so that's 4C. So now we can go down to 5, and that is to simplify. So we're going to put everything together first before we simplify. So right here, our only reactant on this side is elemental aluminum, so Al, plus the reactants over here, 3 electrons plus 3 silver ions, yields our products, aluminum ion. Remember, with ions you must write the charges, plus 3 electrons plus 3 silver atoms. Okay, now these 3 electrons aren't actually in the reactants and the products. This is just showing that they're being transferred from the aluminum on this side to the silver on this side. So those actually cancel out, leaving you with our complete redox reaction. So step 6 is just to write it out without the electrons. If you look back at the original equation, you'll see that it didn't really look like it needed to be balanced. There was 1 and 1 and 1 and 1. But now we have these 3s on the silvers. So this is why you must balance it this way using the electrons, because even though it may look like all the atoms are balanced, because of the changes in oxidation number, they aren't really balanced because of how many electrons need to be transferred. So you must do it this way. Alright, I'm about to move on to the next slide. If you still need to write down these steps, please feel free to use the pause button. Okay, this is another example of an oxidation reduction reaction, or a redox reaction. What I would like you to do now is use your steps from the previous slide to try to solve this, balance this on your own using those 6 steps. And you need to go ahead and pause the video, and then when you come back, I'll show you how to do it so you can go back and check your work. Go ahead, hit pause. Don't be scared. Do it. Alright, hopefully you pause the video. And now I'm going to show you what your work should look like. So if you haven't already done all of your work, pause the video now and finish it up so that you can check it with my work. And this is what your work should look like. If you need time to check your work and to write this down, then please pause the video. But other than that, I'm going to move on. Okay. Now there's one more situation that you need to know how to handle, and that is when redox reactions are occurring in acidic solution. It changes the way you balance them, because not only is all of this stuff going on in your beaker of solution, but you also have an acidic solution. And what do acids add to solution? Well, I'll tell you, H plus ions. And solution means that it is in water. So in addition to all of this going on, we also have H plus ions and water, and we'll use those to balance our reaction. The first step is still the same though. You're going to assign oxidation numbers. Oxygen is always -2. 7 times -2 is -14. To get from -14 to our total of -2, you need +12, but there's 2 chromium, so each one has to be +6. Iodine is -1, chromium ion is +3, -2, and +5. Second step is the same as well. Identify reduction half reaction and oxidation half reaction. So oxygen doesn't change. Chromium goes from +6 to +3, so it's going down. So that means it's reducing. Iodine is going from -1 all the way up to +5, so it is being oxidized. And now we can write and balance the half reactions. There's a couple more steps, as you see, in balancing the half reactions. So let's do them one at a time. Let's start with our oxidation half reaction. Once again, it's very important that you leave yourself plenty of room on either side of the reaction. So I'm going to start right here with my iodine ion, going all the way to iodine trioxide. Now, to balance it, 4A says balance all elements except hydrogen and oxygen. So in this case, that's just iodine, which is already balanced. Then 4B says you're going to balance your oxygen by adding water, because you'll notice that there's no oxygen on the reactant side. So where did this oxygen come from? Well, it came from your acidic solution. So we're going to balance our oxygens by using the water molecules that are available. So if you need 3 oxygens, you have to add 3 waters over here. All right. 4C is to balance the H's by adding H pluses, because now that we have water over here, we have to balance our hydrogen. But since it's in acidic solution, we have all these H pluses floating around. So 3 waters means 6 hydrogens. So you'll add 6 H pluses over here. Okay, now everything is balanced. So 4D is to add electrons to balance the charges. Now we have more charges to deal with here than we did before because of our addition of water and these ions. So we're going to add up all the charges on either side and see what we've got. Well, water is a neutral molecule, so no matter how many waters you have, it will always be 0, because anything times 0 is 0. So on this side, the only charge we have is -1. Over here, though, we have a -1 charge for iodine trioxide, because of this right here. So this is -1. But then we have +6 from our 6 hydrogen ions. So -1 plus 6 gives us +5. So we've got -1 here, +5 here. So that means we need to add 6 electrons to this side, because now we've got 5 minus 6, because electrons are negative, to give us -1, and those are now balanced. So we add 6 electrons. Okay. So once again, 4E is going to have to wait until we have our reduction half reaction. So for our reduction half reaction, we've got dichromate, Cr2O7 2- yields ignore that bell, Cr3+. Okay, so first we need to balance our chromiums because they're not oxygen or hydrogen, so we got to put a 2 here. Then we'll balance our oxygens by adding 7 waters. Then we'll balance our hydrogens by adding 14 hydrogen ions. And then we need to talk about charges. We've got +14, -2, that gives us 12. Over here we've got +6 and 0 to give us 6. So remember, electrons can only bring numbers down because they're negative, so we have to add the electrons to the bigger number. To go from 12 to 6, we need to add 6 negative electrons, which actually works out really well for 4E because we have 6 electrons being donated as well as 6 electrons being gained, and so there's no balancing of electrons to do. So now we put it all together just like before, leaving yourself plenty of room to write, so I'm going to start right here. So we start with our reactants here and here. So 3H2O plus iodine plus 6 electrons plus 14 hydrogen ions plus dichromate 2- yields, back up here to the products, iodine trioxide, charge of -1, plus 6H plus 6 electrons, plus 2 chromium ions, plus 7 waters. Barely fit. Okay, So now we can simplify. Just like before, we can cross out these electrons because they're not really there, they're just being transferred. But also, we can cancel out some of our waters and some of our hydrogen ions. So if you have 3 waters over here and 7 waters over here, you can essentially subtract both sides by 3 to combine your like terms. So the 3 waters go away, and then those 3 waters cancel out 3 out of the 7, leaving you with 4 waters on this side. Same thing with the hydrogen ions. You got 14, you got 6. So the 6 cancel out, and then those 6 cancel out 6 of these, leaving you with 8. And your final complete redox reaction is going to be I minus plus 8 hydrogen ions plus dichromate complete with its charge yields iodine trioxide complete with its charge plus, you can skip all over this, 2 chromium ions with their charge plus 4 waters. And a way to check your work on these is just to make sure that it's balanced at the end. 1 iodine, 1 iodine. 8 hydrogens, 8 hydrogens. 2 chromiums, 2 chromiums. 7 oxygens, 3 plus 4 is 7 oxygens. So this is balanced. Okay, I'm going to move on to the next slide. Feel free to pause if needed, or rewind even and listen to what I said again would be fabulous. Okay, here's one for you to do. So using the steps, pause the video and solve this on your own. When you come back, I will have the answer for you. So go ahead, pause, do it. Pausing now. Thank you. And this is what all your work should look like. If it does not look like this, then you need to pause this video and look at it carefully and figure out where you went wrong and learn. This is the last slide in the video. We will be going over this in class when I see y'all on Monday. My suggestion is that you go back and now watch this whole video one more time without trying to write down everything that I'm writing down so you can kind of absorb it. But other than that, thanks for watching. We'll see you soon. Bye-bye.